In this project, we will build a model to predict the electrical energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. So we have a set of 9568 hourly average ambient environmental readings from our sensors at the power plant, which we will use in our model. So these variables are temperature, ambient pressure, relative humidity, and exhaust volume, and all these have us different units. So temperature is in degrees Celsius, pressure is in millibar, relative humidity is in percent, and the exhaust volume is in centimeters, right? And we need to predict one output variable, which is net hourly electrical energy output from the power plant. So this is a target variable, and based on the four input variables which are on a different scale, we need to predict this output variable, which is a continuous variable, and the input variables are also continuous. So there is no scope for hot encoding, since we do not have a categorical variables, and since the output variable is linear, so the problem becomes a regression problem, right? So in this problem, I have used these four temperature or environmental variables as an input variable, and the used electrical energy output as a output variable, or say target variable. I have also used a standard scaler to scale my variables, so that the input variables are on a same scale, so there is no skewness in the input variable side. And I have also checked the data for the normal distribution, and since I have used scaling, so also the input variables distribution was normal. And now I have used a Python sklearn libraries, which are pandas, seaborn, matplotlib, to check the distribution or plot distribution of these variables, and sklearn. From sklearn, I have used a few modules, which are like model selection, linear model, and a few more. So I have used standard scaler to scale my input variables. I have used a train test split in a 80:20 ratio for train and test, and I have used a random state of 100, right? And after scaling my input variables on the input train features, I have used a linear regression model, and which has given predicted variable as an output, and I have calculated the accuracy of the model using the R square value, and the R square value for this is 92.8, and which is very nearer to 100%, or on a scale of 1 it is 0.928, which is very nearer to 1. So the model prediction is generally good, because it's a very small data set of around 10,000 input observations. So the output is slightly good, and I have also calculated mean absolute error, which is around 3. So that also gives a slightly better model performance on a simple regression problem. So thank you. That is all what I have done in this modeling task.